Napier used indices to come up with logarithms. In this video, we get to introduce ourselves to logarithms. This is Kisembo Academy, and thanks for tuning in. Right on your screen, you see 10 to the power 5 is going to be equal to 10 times 10 times 10 times 10 times 10. We earlier said that this power 5 means that this 10 has been multiplied 5 times. And the answer we are getting here is 100,000. Now, if we are to find the logarithm of 100,000, the logarithm of 100,000 is going to be equal to 5. That is, if that logarithm is to base 10. Why do we say so? Because you're going to have to raise 5 to base 10 for you to be able to get 100,000. By saying all that, I'm trying to derive the definition of logarithms. In essence, the power to which 10 must be raised in order to give 100,000 is called the logarithm to base 10 of 100,000. So it means the log of 100,000 is going to be 5 base 10, and that is the definition right on your screen. Take a look at this number. This is 100,000. From our definition, what is the logarithm of 100,000? Now the logarithm of 100,000 is going to be the power to which 10 must be raised for us to be able to get that 5. If you look at 100,000, it is 100,000, meaning it's having 1, 2, 3, 4, 5 zeros. Now to what power should we raise 10 so that for us to be able to get 100,000? Of course, we are supposed to raise 10 to the power 5. If we raise 10 to the power 5, then we'll be able to get 100,000. So that power to which 10 must be raised in order to give this 100,000 is what we are calling the logarithm to base 10 of that number. So meaning that the logarithm of 100 to base 10 is 5. That's why here that the logarithm of 100 to base 10 is going to be 5. Now take note that this has been to base 10. So let's look at other illustrations. Now, what is the logarithm of 16? Here the logarithm of 16 is going to be 4, but this time it won't be to base 10 because it is 2 to the power 4. So you're raising the power 4 to a number 2, not to 10. So the logarithm of 16 here is going to be 4 base 2. That's why we are saying that the log of 16 is going to be 4, but it's to the base 2. So let's do a few examples. What is expressed in the form of logarithm? So what's the log of 8? Simple. The logarithm of 8 here is going to be 3. But what's the base of the logarithm? It's 2. So it's base 2. Likewise here, what's the log of 1? So the logarithm of 1 is going to be 0, but it is to base 10. Getting on to our next illustration, converting this number to logarithm, the logarithm of 3 is going to be a half. So it's going to be a half, but it is to base 9. Likewise here, the logarithm of this number 5625, the logarithm of 625 is going to be equal to 4. But what's the base? 5. As simple as that. Now, if you look at these numbers that we've just done, these numbers and this number, if you are to try and convert them back to index form, this is the pattern. So the pattern here will be 2 to the power 3 is supposed to give us 8. 2 to the power 3 is equal to 8. And this one takes us back to this. Likewise here, 10 to the power 0 is equal to 1. 10 to the power 0 is equal to 1. It takes us back to that. In the same breath, we are going to convert these numbers to index form. They are telling us that the log of 8 base 2 is equal to 3. Converting that to is still going to be, we shall say it's 2 to the power 3 gives us 8. So 2 to the power 3 is going to be equal to 8. As simple as that. Now we've converted this logarithm to index form. It's the same thing we shall do here. 10 to the power 0 is equal to 1. Then also, just like before, it's going to be 9 to the power half is equal to 3. And also here, it's going to be 5 to the power 4 is equal to 6 to 5. So it's 5 to the power 4 giving us 6 to 5. So that's how you're going to juggle between logarithms and indices. You can convert an index into a logarithm and return it back to where it was. In this video, we shall get to look at some of the properties of logarithms. Thanks for tuning in. It's Kisembo Academy. Now, when we're looking at the properties of logarithms, we are looking at how we add logarithms and subtract them. The first property is how we add logarithms. This is log x to base 10, log y to base 10. When we add this to that, when we are adding two logarithms and they are having the same base, for this case it's base 10, base 10, what you do is that you will add the numbers. So in this case, you're going to multiply the numbers. When the base is the same, base 10, for example here, you shall multiply x by y. When it's addition, you multiply. So it's going to be log base 10. You maintain the logarithm and its base, and then you multiply the numbers. When you're subtracting logarithms that are having the same base, in this case it is base 10 and base 10 here. So you're going to maintain that logarithm to the base 10, and because it is subtraction, you divide x by y. And also the other property that needs to be committed to memory is that log base 10 of x to the power p is the same as that p coming right here. It's the same as p times that number itself. So about these properties of logarithms, please take note that these properties are only going to work when the coefficient of the logarithm is 1. So it means if you're given a number where the coefficient of these logarithms is not 1, it means you're supposed to first, for example, this logarithm, the coefficient of log of x base 10 here is p. So before you apply any of these, either this or that, it means you're supposed to first make sure that this coefficient is 1. So how do you remove this p? By putting it up here, using this property. When the logarithm of a said number and the base is the same, the answer is always equal to 1. For example here, when the number and the base are the same, the answer is always 1. For example, the logarithm of 10 base 10 is 1. The logarithm of 3 base 3 is equal to 1. The logarithm of 2 base 2 is 1. And if you look at all these logarithms, if you're to convert them to index form, it is 10 to the power 1 is equal to 10. 3 to the power 1 is equal to 3. 2 to the power 1 is equal to 2. So this is another property that should be at the back of your head when you're interpreting numbers of logarithms. In the examples we are going to do, in instances whereby the base of a logarithm is not given, we assume that the base is 10. In our first works example, they're telling us to find logarithm of 27 plus logarithm of 3. Now here the base is not given, so it means it is base 10. That is the assumption. So this is 10 and that is 10. So we'll go ahead and work. You'd realize that 27 can be prime factorized and converted into an index, into index form. So 27 by 3 is 9. Divide by 3, you get 3. So 27 is the same as 3 to the power 3. So it means this can become, or it becomes the log of log base 10 of 3 to the power 3 plus log base 10 of 3. Now, so using this property here, we shall say it's going to become 3 times the log of 3. This 3 comes right there, plus the logarithm of 3. And of course here it's like saying 3x plus x. So 3 log 3 plus log 3 is going to give us 4 log 3. In our next example, still the base is not given, so the base 10 will be assumed all through. So we'll go ahead and find log 25. Now, the logarithm of 25 is going to be, we factorize this 25 first. 25 by 5 is 5. So it means that this is the same as saying log of of 5 squared plus, now this is 5 log 2. This 5 can be taken back up there, so it's becoming log of 2 base 5 minus log of 5. Now here we are having logarithms, they are of the same base. So because they are of the same base, we shall maintain the same log. It's going to be log of the same base, which is log 10, into, now you add this, it's going to be 5. This is 5 plus 2. It means you are going to say it is 5 to the power 2. Multiply that by 2 to the power 5. Since this is minus, it means we shall divide by 5. And so definitely our answer here is going to be, our logarithm will be 5 squared. The 5 squared, this 5 will cancel with one of those 5s. You remain with 5 times 2 to the power 5. So as you realize in this number, when we started it off, we had to first make sure that the coefficients of these logarithms are 1. If you look at all these logs, this is 5 log 2, the coefficient of this is 5. So to first make sure that for us to apply any property of this logarithm, either addition or subtraction, we had to make sure that each coefficient of the log here was 1. So that's why we shifted that 5 to come up there. That is why we have it in the next step like that. And then after making sure that each coefficient of the logarithm was 1, then we went ahead and applied the properties of logarithms, that when you're adding properties, you multiply these numbers. 5 times 2 to the power 5, divide that by, because it's minus now, this minus 5, divide by 5, and we get our answer like that. This number right here, it is log 2 minus log the square root of 2. We are required to solve it. Now, these two logarithms are having the same base 10. So since they are having the same base, and the coefficient of this logarithm and the coefficient of this logarithm is 1, so it means we can apply the property of logarithms, the property of subtraction of logarithms, that when you're subtracting logarithms with the same base, for the instance here it is base 10, you simply divide the powers. You simply divide the numbers. So in this case, we shall maintain the log with its base. So it's log base 10 into, since it is subtraction, we divide. It's 2 divided by the square root of 2. So 2 divided by the square root of 2, we are going to rationalize this denominator. This is a third. So this is going to become the logarithm of 2 root of 2. When we rationalize this denominator, it means we are going to multiply square root of 2 here times the square root of 2 down here, and up here times the square root of 2 up and down. So that our new logarithm here is going to become 2 times the square root of 2. Divide that by root 2 times root 2 is 2. So we shall remain with log of root 2. These 2 and that 2 cancel, remain the log of root 2, which is the same as the logarithm of 2 to the power a half. And the logarithm of 2 to the power half, when this a half comes right there, is the same as a half log of 2. And that's the answer. Now we're able to solve that number. That is when you have the knowledge of rationalizing of the surds. Now, rationalizing of surds is another topic under surds that we have done here at the Kisembo Academy. But we can do this without having to apply this rationalizing of surds. We can still look at this and simplify it in this other way. Now, logarithm of 2 minus log of root 2 can be, we can simplify it. The next step can be, it's going to be the log of 2 minus the log. Now square root of 2 is the same as 2 to the power a half. This is the same as log of 2 minus, now this a half comes right there, it becomes a half times the log of 2. Now log of 2 minus a half log 2, it's like saying x minus a half x, and of course here the coefficient of this log here is 1. So 1 minus a half will give you, the answer will remain as a half times the logarithm of 2 as the answer. It gives us the same answer as we got in the other first method. So going on to this other number, we have the logarithm of z plus log of 1 over z. Still here it is addition of logarithms, and each of these logarithms, its coefficient is 1. So what we shall do is simple. We simply maintain the logarithm with the same base and we multiply the numbers. So it's going to become z times 1 over z. And definitely the answer there is the logarithm of, this z goes with that z, log 1. Log 1 is that answer, and it's base 10. We said that when the base of a logarithm is not given, it is assumed to be 10. In our next example, we are having logarithm of 2.4 plus logarithm of 75 minus logarithm of 150, and all these ones are to the base 10. So since they are all to the base 10, we shall maintain the base, and then we deal with the numbers. Now it's this plus that, this is addition, so we are going to multiply this number by that number. Then minus 150 means we are going to divide by 150. So we begin. It follows that it's going to become the logarithm to base 10. Here 2.4 plus 75 means you are going to multiply them. It's going to be 2.4 times 75, then divide that by, because it's minus 150, so over 150. So our answer here will be log base 10 of 1.2. And that's our answer. We have another here, log of 10. All these ones have log of base 10, and their coefficients all the same. The coefficient of this is 1, the coefficient of this is 3, the coefficient of this is 1, 1. So this one of 3, we are supposed to shift it and put it on top of that using the other property. So it means that our next step here will be the log base 10 of 81 over 32 plus, now here it's going to be log to base 10 of, this is 5 over 3 to the power 3 plus log to base 10 of 1 over 9 plus log to base 10 of 768. Then since it's all through its addition and we are having the logarithm, they are all of the same base 10, so we shall maintain the base. It's going to become log to base 10 into, so since it's plus throughout, so it's going to means the numbers are going to be multiplied. We multiply this by that, by this, by that. So it's going to become 81 over 32, multiply that by 5 over 3 cubed is the same as 5 cubed over 3 cubed, multiply that by 1 over 9, multiply that by 768, and definitely our answer here will be, our answer here is 1000. Now this is the same as log to the base 10 of 10 to the power 3, because 10 to the power 3 is 1000. 10 to the power 3, we are simplifying it further, and so when this 3 gets down here, it becomes 3 log 10 base 10. And any number, when it's having the same number and the same base, this is equal to 1. So it's going to be 3 times 1, and the answer here is 3. We have log of 9 over logarithm of 3. We simplify this. This is going to be equal to, now 3 is the same, log 9 is the same as 3 squared. These logarithms are having the same base, so the base is 10. So it's going to become log of 3 squared, because 3 times 3 is 9. So it's log of 3 squared divided by log of 3. So when this 2 comes and shifts comes here, it becomes 3 times the log of 3, divide that by the logarithm of 3. And our answer will be this, and that will cancel. You remain with 3 as your answer. So right here we are having logarithm of the root of 8 divided by this, the third root of 2. We convert this into in the index form, so it becomes this is equal to the log of 8 to the power half, divide that by logarithm of 2 to the power, now this is the third root, so it means it's to the power a third. So it means this is going to become when this a half comes right there to become the coefficient, it becomes a half the logarithm of 8 over a third times the log of 2. Now when you look at 8, if you were to factorize 8 so that it looks like this logarithm down here, by 8 by 2, when you divide 8 by 2 you get 4. When you divide 4 by 2 you get 2. So it means 8 is the same as 2 to the power 3. So you can replace this with 2 to the power 3. So this is the same as a half times the logarithm of 8 is 2 to the power 3. Divide that by a third times the logarithm of 2. Now definitely this 3 is going to come and join up here with this. So this is going to become, when this 3 comes and joins up here, this is going to become 3 over 2 times the logarithm of 2, divide that by a third times the log of 2. So this log of 2 and that log of 2 cancel out. You remain with 3 over 2 divided by a third. Now 3 over 2, divide that by 1 over 3, is still going to be 3 over 2 times 3 over 1. And definitely our answer here will be 9 over 2. This brings us to the end of this worked example. Thanks for tuning in. Up next, we shall be doing more of these worked examples, logarithms. For Kisembo Academy, this is Arnold Rangakoramia. Here we are required to find the value of x. So, using the property of subtraction of logarithms, we know that x, this logarithm is to base 4, and this logarithm is to base 4. And since it is subtraction of logarithms, it means it's going to be x divided by 7. So we maintain the base, it will become log to base 4 into x over divide by 7 is going to give us 3 over 2. When you're subtracting logarithms that are having the same base, in this case it is base 10 and base 10 here, so you're going to maintain that logarithm to the base 10, and because it is subtraction, you divide x by y. Now we convert this logarithm into one indice so that we're able to get the value of x. And in this case it's going to be 4 to the power 3 over 2 is going to give us x over 7. So this becomes 4 to the power 3 over 2 is going to give us x over 7. These numbers and this number, if you are to try and convert them back to index form, this is the pattern. So the pattern here will be 2 to the power 3 is supposed to give us 8. 2 to the power 3 is equal to 8. And this one takes us back to this. Likewise here, 10 to the power 0 is equal to 1. 10 to the power 0 is equal to 1. It takes us back to that. Now 4 to the power 3 over 2 is the same as 4 to the power a half to the power 3, because we know that a half times 3 gives us 3 over 2. Now 4 to the power half is the same as the square root of 4. The square root of 4 here is 2. Square root of 4 is 2, so it's going to be 2 to the power 3 is equal to x over 7. So to make x the subject of the formula here, we multiply both sides by 7 here and by 7 right there, so that this 7 and that die. You remain here with the value of x as 7 times 2 times 2 times 2, which gives us. To find the value of x here, this is 3 times log of 4 base 2 is equal to x. So we make sure that we can convert this to index form. To convert this logarithm into index form, this logarithm must have the coefficient of 1. So we shift this 3 to bring it up there. So this becomes logarithm of 4 base 2 to the power 3 is equal to x. So it means that it's going to be 2 to the power x is equal to 4. Converting this log to index form. So it's going to be 2 to the power x is going to give us 4 to the power 3. And if you look at this 4 is the same as 2 squared, because 4 by 2 is 2. 2 times 2 is 4. So 2 to the power x is going to be 2 squared. 2 squared is 4. So it is 2 squared to the power 3. This is the same as 2 to the power x being equal to 2. 2 squared times 2, so this is the same as 2 times 3, which is 6. So it's going to be 2 to the power 6. Now you realize here 2 to the power x is equal to 2 to the power 6. The bases are the same. So if the bases here 2 and 2, the bases are the same, it also means that the powers are supposed to be the same if the bases are the same. So meaning here our value of x is 6. Therefore, our value of x here will be 6. So here we are required to find the value of x still. All this equation is equal to 5. These are all having the same base 9, and they are being added. So using the property of addition of logarithms, we are going to multiply these terms. So we shall maintain the base, which is going to be the log to base 9 into x times x squared times x cubed times x to the power 5. So this is going to become x times x squared times x to the power 3 times x to the power 5 is going to be equal to 5. So this is going to become log to base 9 of x to the power 11 is equal to 5. So when you convert this to index form so that you're able to get the value of x, it's going to be 9 to the power 5 is equal to x to the power 11. So it is 9 to the power 5 is equal to x to the power 11. Now, of course, to get rid of that 11, you find the 11th root on both sides. So to get the value of x here is the 11th root of 9 to the power 5, which is so to get the value of x here, it's going to become x here will become the logarithm to the base 4, the logarithm of 8. Now we shift this 2, we bring it right there, so it's 8 squared. And you know that 8 squared is 64, so it's going to be log to base 4 of 64 is equal to x. So now when we factorize 64 using 4, divide through 4 by 64, we know that by 64 by 4 it's going to give us 16. When we divide that by 4, it gives us 4. So it means that this is the same as the logarithm of 4 base 4 to the power 1 to 3 is equal to x. So this is the same as 3 log of 4 base 4 is equal to x. And definitely, of course, this, when you're having a number log of 4 and then its base is the same, this is equal to 1. So it's going to be, x is going to be equal to 3 times 1, which is 3. So therefore our value of x is 3. In this number, we are being required to find the value of x using logarithms. So in using logarithms here, to find the value of x, we are going to introduce logarithm of base 10 on both sides of this equation. So we shall introduce log this way and log that way, and we proceed. So this is going to become the logarithm to base 10 of 3 to the power x is going to be equal to the logarithm to base 10 of 6. So definitely, of course, this x will come right there. It becomes x times the log of 3 is going to give us the logarithm of 6. So x will become log of 6, divide that by logarithm of 3. So our answer here will be 1.63. Still, we are required to use logarithms to find the value of x here. We are going to do it like before. We are introducing logarithms to base 10 on both sides of this equation, so it's going to become the log of 0.176 to the power x is going to give us the log of 0.415. So this value of x gets there, so it becomes x times the log of 0.176 being equal to the log of 0.415. When you divide both sides by the log of 0.176, this goes with that. You remain with the value of x as you get 0.5062. We are required to solve here for the value of x using logarithms. Again, we are going to introduce logs on both sides. So this is going to become the log of 5 to the power 3x plus 3 is giving us the log of 9 to the power x minus 4. This becomes 3x plus 3 times the log of 5 being equal to x minus 4 times the logarithm of 9. When we open brackets here, it's going to become 3x log of 5 plus, this times that is 3 log of 5 is going to give us this times that, which is x times the log of 9 minus 4 the log of 9. So we shall collect like terms. We shall put those terms that are having unknowns on one side of the equation and those terms that do not have unknowns on another side of the equation. So in this case, we require this to get that way. So it's going to become 3x times the log of 5. When this one comes this way, it becomes minus x. The log of 9 is going to be equal to, here we have negative 4 log of 9. Then this one also needs to go that way, this one. So it's minus 3 times the log of 5. So here we factorize out x. So x is outside the brackets into 3 times the log of 5 minus log of 9 is going to give us, this is negative 4 log of 9 minus 3 log of 5. So when we make x the subject of the formula here, we shall remain with, when we make x the subject of the formula here, we shall remain with x being equal to this, which is negative 4, the logarithm of 9 minus 3, the log of 5, divide all that by 3. Log of 5 minus log of 9. And our value of x here will be In this video, we are going to look at how we handle negative characteristics of logarithms. We have an example, an illustration on our screen. If you look at the logarithm of 0.005 base 10, turning this 0.005 into standard form is going to be log to the base 10 of 5 times 10 to the power negative 3. This is the standard form of this number. Now, because it is in brackets, when you open these brackets, you're going to have log of 5 base 10, which is this, plus, since this is multiplication, so it's going to become plus log log of 10 to the power negative 3 base 10, which is this. Now, when you look at these two terms, you're having a negative to the power negative 3. It's a negative characteristic of the logarithm, because when you get this negative 3 right there, you remain with negative 3 as this becomes 1. So it means that you're having a negative characteristic right there. And in such cases, this positive one is called the mantissa, and this is the negative characteristic we are talking about. Now, in this video, we want to learn how we deal with these negative characteristics. So, when you continue, when you find the log of 5 in your tables, it is 0.6990. And definitely this is going to remain as negative 3. But we treat it as 3 bar, not negative 3, because when we add this to that, as far as logs are concerned, we are going to add the mantissa separately, and the characteristic, the negative characteristic, will be added separately. So it means that when we add this and that, it's like we are adding negative 3 plus this. But in actual sense here, the answer here now is negative 3.6990. But this negative 3 is independent of this other term. This negative 3 is the characteristic, and this other part of the number is what we are calling the mantissa. And these two are independent of each other. So negative bar 3.06990 is not the same as negative 3.6990. These are different. This negative means that it affects the whole term, the whole number. But when we say 3 and you just put the negative on top, which I'll call 3 bar, it means that this negative term, this negative only affects that number 3. We'll use more illustrations to make this more clearer. Let's look at this example. This is a logarithm with a characteristic 4 bar 0.7321 and this. And we are being asked to add them. So how do we add these? It's simple. We simply say that 0.7321, to add this, it becomes 2.0526. When you add those two, you're going to add the mantissa. This is separate from that. So this negative only affects this characteristic. It does not affect the rest of these. So these ones are not taken as negatives. So when you're adding, this is 6 plus 1, which is 7. 2 plus 2, which is 4. 5 plus 3 is 8. 7 plus 0 is 7. Then we have our decimal point right there. Then now here we're having negative 4 plus 2. Negative 4 plus 2 is going to give us negative 2, and we shall write it like that as 2 bar. We have another illustration, another example. This is a 3 bar 0.4, 3, 2, 1. To add this, 1 bar 0.8, 4, 2, 2. In adding those, still we treat the characteristic side independently of this side. So these ones are positives. 1 plus 2, this is 3. Then we have 2 plus 2, which is 4. We have 3 plus 4, which is 8. We have 8 plus 4, which is 12. So this is becoming 2. We carry 1 here. So it becomes 1 minus 3 minus 1. So 1 minus 3 is going to give us negative 2. The negative 2 plus negative 1 will give us negative 3. So this becomes bar 3. So it's bar 3.2843. That's how we deal with that arithmetic. Next, we have now subtraction of these subtraction of these characteristic and mantissa of these log forms. So here we shall say it is 2.6249, that is minus this 2.2.413. Oh, it is 2.4135. This 2 is right, not there. So when you have to subtract those, it's going to become 9 minus 5 is going to give us 4. 4 minus 3 is going to give us 1. 2 minus 1 is going to give us 1. Then 6 minus 4 is going to give us 2. Decimal point. Then we shall add this. This negative only affects that number. It does not affect the rest of this part. So it's negative 2 minus 2. That's giving us 4 bar. Negative 2 minus 2 is going to give us negative 4. So how do we multiply them? Multiplying them is going to be, so 2 times 5 is 10. So you write here is 0, you carry 1. 7 times 2 is 14. 14 plus that 1 is going to give us 15. So you write 5, carry 1. 2 divided by 3 is 6. 6 plus 1 is 7. Then 2 times 4 is 8. Then we have 2 times 3 bar. 2 times 3 bar is 6 bar. So when we are multiplying these numbers, when we are multiplying logarithms, because this is a logarithm, we do it in such a way that we are going to multiply this by the characteristic will be multiplied independently from this. So it means that the answer here we are getting is 6 bar 0.8750. If you look at it this way, this is like saying 2 multiply that by negative 3 plus 0.4375. This is how you should look at it. That this negative 3 is independent. 2 times negative 3 gave us negative 6. Then 2 times 0.4374 gave us 0.8750. That is how we should look at it. Let's look at the next example. Now still, when you're multiplying this is the same as saying 4 multiply that by negative 4 plus 0.62401. We are going to multiply the two independently. So this negative only affects this part. This is free of that. It's still positive. So it's 4 times 1 is 4. 4 times 0 is 0. 4 times 4 is 16. So 6 carry 1. 4 times 2 is 8 plus 1 is 9. 4 times 6 is 24. So you write 4, you carry 2. So 4 times negative 4 is going to be negative 16. Negative 16 plus 2 plus positive 2 is going to give us negative 14. So it becomes bar 1 4 point, like that. And that is how we multiply logarithms with negative characteristics. Now we are going to look at how we divide logarithms with negative characteristics. We shall do it with an example. We are supposed to divide 5 bar 0.2514 divided by 3. Now we're looking at this is a logarithm, a log number that is having a negative characteristic. Now, when the characteristic is positive, first of all, division will always be carried out in the usual way. This is the characteristic we are talking about, and this is the mantissa. So when the characteristic is positive, division is in the usual way. But then, if the characteristic is negative, like the way we are seeing in this example, then the logarithm is going to have to be rearranged to make the operation possible. Now, in such cases, the negative characteristic is increased to the next integer so that it is divisible by the dividing constant. If you look at this number here, if you look at this characteristic, this negative characteristic, you realize that 5 is not divisible by 3. So what do? We are supposed to increase this negative characteristic to the next integer so that this characteristic is divisible by 3. So in our example, it means that this here, our next step is going to be, we're supposed to increase this. So this is going to become 5 bar is supposed to add plus 1. Because 5 plus 1 is going to give us 6, and 6 is divisible by 3. So it's going to be 5 plus 1. Then that is going to be the characteristic. We deal with it independently. Then it's going to be plus. Then we have this other 0.2514. Now this one, since we added 1 here, we're supposed to also add 1 here to make the whole thing uniform. Divide that by 3. So definitely here what we have is 6 bar plus, this is going to be 1.2514. Divide that by 3. And of course here the answer is 3 divided by 6 bar is going to be 2 bar. 2 bar plus 1.2514 divided by 3 is still going to give us 0.4171, and our answer is going to be 2 bar 0.4171, and that is our answer. Looking at this next example, it's just more like the one previously. If you look at this negative characteristic, it is 2 bar. This 2 bar is not divisible by 5, so we're supposed to add something to this, to the next nearest integer, so that it is divisible by 5. If you look at this 2 bar, if we add 2 plus 3, we are going to make 5. So if you're adding 3 here, it means you're going to add 3 here as well. So it means this is going to become this 2 bar. We're supposed to add 3 so that it becomes 5, so that we are able to, it's divisible by this. So it's, well, you shall add plus 5 bar plus, so this is the negative characteristic, then the mantissa, we deal with it separately. So it's going to become plus, this is going to be 0.3451. Since we added 5 here, it means, we added 3, it's supposed to be 3. Sorry, it's supposed to be 3 bars, so that 3 plus 2 is 5, and because 5 is what is divisible by this. So since we added 3 here, so it means that this we are supposed to also add 3 right there. Divide that by 5. So we shall end up with 3 plus 2, which is 5 bar, plus this plus that gives us 3.3451. Divide that by 5. So our answer here will be, of course, 5 bar divided by 5 is going to give us 1 bar, plus 3 point this divided by that is going to give us 0.6692. So our final answer will be 1.6692. So the most important thing here that we need to take note of is that we added here 3 bar, and also onto the characteristic we added 3, and then on the mantissa we also added 3. Why? So that we are able to get these numbers divisible by 5. This brings us to the end of this video. Thanks for tuning in. I encourage you to subscribe for more of these videos. For Kisembo Academy, this is Arnold Wanga.